Welcome to Stormwater Drainage Solutions. In this video, we're going to be talking about whether corrugated or PVC pipe is the superior pipe or not. We're going to be showing some demonstrations here and just going over in general what the math says and what the math shows. So I have cut these two pipes open. That way we can really get an idea of what's going on inside the pipes as water is flowing. Now, granted, we can't put a massive amount of flow through here because I am limited to only being able to use the pressure coming out of a garden hose. But either way, we'll have to make this make do. So basically, I've always been a big proponent of the pipe type is determined by the application and by the budget and the job site and what exactly it is you're trying to accomplish. And I will always stick by that because I believe that that is and will always be the truth. The very first thing we're going to demonstrate here on our corrugated pipe is a low flow application. By opening the garden hose only slightly, we're going to send a certain amount of water through the line here. You can see the water has to build up in each corrugation as it pushes its way down the line. Now, both of these pipes, the corrugated and the PVC, are set at 2% slope because that is the grade that I had to work with on top of the ground here in the backyard. Now, the thing about corrugated pipe, every manufacturer of this pipe recommends 2 to 4% slope to have this pipe be self-cleaning. As the water makes its way down and hits each corrugations, it does stir up sediment and debris and it continues to push it down the line. However, 4% slope is optimal. The more slope you can get with this pipe, ideally, the better, because it will push dirt and sediment through much more efficiently. But if you are working in a flat yard, then ideally, you do not want to use corrugated pipe. Now, we've turned the garden hose up here for a higher flow application. That way we can get an idea of what this looks like running through the pipe here. Now, the other thing that is failed to mention a lot, and I probably actually have never heard it mentioned, is the amount of rainfall that you get through a year. It greatly determines how much debris ends up sitting in this pipe. So what I want to try to explain the best I can with this is, let's say on one season you get an adequate amount of rainfall. So you have a properly installed corrugated system with good slope, at least 2% or more, and you are getting a ton of rainfall that year. The chances of debris buildup in that pipe are going to be a lot less because you have such an increased flow rate and gallons per minute flowing through that pipe, and the volume of water is moving that debris constantly and pushing it through. So let's say the next year the rainfall is not quite as much, and you're only getting a little bit here and there, and it is constant low flow applications. If the pipe is only flowing a small amount of water, debris and sediment and contaminants will still get into that system and in that pipe and will settle at the bottom. And because it continuously only has a low flow application over each rain, that debris and sediment is actually gaining ground, and it is having a chance to start to build up in sections and places in the pipe, compared to if the following season you start to get heavy rains constantly, then more water and more head pressure will be pushed through that pipe and will move that debris out. If you get limited rain a couple of years in a row and you do not have as much volume going through that pipe, that is enough time for a lot of sediment and debris to build up in there and start to create problems. And then once you do start to get heavy rains that come through that pipe, it may not be able to move that debris through because the clogs have already started to develop. So that is something to keep in mind with corrugated pipe, and that is something that we have seen out in the field depending on the season and how much rainfall and water flow that we got that season. The next topic we're going to be covering in this video is called the Manning's equation, because at the end of the day, math does not lie, and we can figure out a lot with math. So the Manning's equation, it was born in 1890. It is still the most widely used and accepted formula for calculating the hydraulic capacity of gravity flow sewer systems. So I went ahead and I put the equation here up on the screen so you can kind of follow along with me, but we're just going to go over it real quick, the equation. So the Q in the equation is the flow rate or discharged. It's measured in cubic feet per second or cubic meters per second. The N is simply the Manning's roughness coefficient. So basically the N is how rough the inner diameter of that pipe material is. The lower the number, the less roughness it has. The higher the number, the higher the roughness it has. It's that simple. The A is the cross-sectional area of the water within the channel, so within the pipe, measured in square feet or square meters. The R is the hydraulic radius, calculated as area divided by the wetter perimeter. This effectively tells you how much of the water is in direct contact with the channel's boundary. So how much water is in direct contact inside the inner diameter of that pipe. And the S simply stands for the slope or friction of slope. So it's the energy grade line, essentially representing how steep that drain pipe is going to be laid. Now let's go ahead and go over the Manning's roughness coefficient N values for different drainage pipe types. I have them up here on the screen for you, and I have them in order from least to greatest. So PVC plastic pipe, we're at a 9. Now I'm not going to repeat all those zeros. Obviously it's 0.009, but I'm not going to say that for every single one. So PVC plastic pipe is at a 9, cast iron is at a 10, reinforced concrete pipe, RCP, is at 11. Vitrified clay pipe, VCP, that's also at 11. HDP dual wall pipe, this is N12 pipe, that is at a 12, hence why it's called N12 pipe. Corrugated metal pipe, CMP, that's at a 17. And then single wall corrugated plastic pipe is at an 18. It's the highest on here. Now, note that these values, all of them, they will increase slightly due to bends in the system, inlet/outlet losses, manhole accesses, and sediment/slime buildup over time in these systems. So all of these numbers are subject to go up slightly. All right, so let's go ahead and throw some sediment in here and crank the garden hose up and see what starts to happen. So we're gonna do the corrugated pipe first, obviously, just because this pipe, has the worst reputation and just has a bad name in general from poor installation and poor quality material choice. But at the end of the day, let's go ahead and let's do kind of a real life scenario here and let's see what happens. So this sediment we threw in here is pretty fine sand and clay fines. So this stuff really likes to sit at the bottom. It does not like to move. And we have the garden hose just kind of on a trickle right now, just to let that water kind of build up. And this is what I was trying to explain at the beginning of the video. If you have a season where it's very minimal rainfall throughout the year and the pipe is constantly at a low flow application state, this essentially is what is happening inside that pipe to any debris and sediment that has built up from the previous year in that pipe. The water has a hard time moving it through. It has a hard time getting around it. It has a hard time pushing it to the discharge end. Now, when we turn this spigot up here, when we turn the garden hose up and we increase the flow rate on it, which you will see here in a minute, the water is going to push that sediment through and it's going to begin to move it through the line. Now, this is only at 2% slope. I feel like I need to keep mentioning that because if it were at 4% slope, it would move it through a lot more efficiently and it would be a lot faster. You can see that water did break through and it is moving the sand and sediment down the line a little bit, and we're still kind of at a low flow application here. I think we have turned up the hose slightly more now. You can see that water is traveling a little bit faster and a little bit harder. So we are starting to break down that sediment patch there and move it through the line. Now, granted, it is settling in a lot of the ridges and the valleys of the corrugated pipe, but it is moving it through. However, it is moving it through slowly. This is why I am a firm believer that each season makes a huge difference, especially in a corrugated piping system, because if you don't get a lot of rain one season and it's just enough to create low flow application and it's just putting dirt and sediment and contaminants into the system, these buildups will continue to happen. And if you have a couple of years in a row where you don't get a lot of rain, then this is ultimately going to build up more and more and more. So ideally, you want to have a high flow through your corrugated pipe to be able to move that dirt and sediment through there efficiently year after year after year. Now, if it is at a 2 or 4% slope, even with the low flow applications, it will continue to move the dirt and sediment, but it's going to be a lot slower. You can see there how the dirt and sediment is beginning to move down the pipe towards the discharge end, but it is less and less and less. So it does take a little while for this dirt and sediment to move through the system, especially because we are just using a garden hose. If this pipe was at least halfway or more full, it would be moving it a lot more quicker and a lot more efficient. So as we continue this little test, we turn the garden hose down. That way you can kind of see how the sediment is slightly moving over those ridges and making its way to the next ridge. Now, obviously on a low flow application, it's going to be a lot less. So here we have the garden hose pretty much turned off. So it is just the last remaining amount of water in the line trying to make its way through. And at this point, you could almost say that we have a smooth interior bottom in this section because the sediment is now smoothed out through those ridges and it is filling each ridge up, creating a smooth bottom in this section here. So let's go ahead and let's get a close-up of turning the water back up and trying to visually see the sediment being moved over each ridge. So we turn the garden hose up very slightly so you can see that water flowing over that smooth bottom section where the sediment has filled in those ridges. And you can see how it is slowly kind of stirring up the sediment that's sitting in each ridge as we turn the water up. I can get the camera down there a little bit closer. I know it's kind of hard to see through the camera, but you can see that sediment and that sand slowly skipping over each ridge. Now, granted, it is very slow though, and we are just using a garden hose to do this. If it was a larger flow where the pipe was filled up more, and if we could gain some more fall on this pipe, it would be moving it through a lot faster. Now we turn the garden hose up here, and you can see that really begins to stir the sediment up, and it moves more efficiently through the pipe. Now, at the end of this test here with the corrugated pipe, we were probably only running this garden hose maybe for 10 minutes. Obviously, the video was cut here and there to save on time, but this would not be as long as a heavy rainstorm, at least here in Florida, would last. A storm here in Florida would last longer than 10 minutes and it'd be a heavier flow of water, being able to move this sediment through the pipe more efficiently. But you can see how that sediment has washed through compared to where we first had put it in the pipe when we began this little test. So it did move that sediment through there. The next testing we're going to be showing you is on the PVC smooth interior pipe here. Now we're going to have that garden hose just on a low flow application to start with to put minimal water through the system, just so you can see how it flows down the pipe. And obviously there's nothing here in the way to hinder it because of the roughness value of this pipe is very low. And we are obviously going to turn the water up higher. That way you can see it flowing through there more with sediment, and we will get to that in a moment here. But basically the only seam on this pipe is at the bell end where that spigot end is, and that's the only seam, and you can see the water is dropping off of that seam. That's why I always stress that whenever you're installing PVC pipe with bell ends, you always want the bell ends facing the direction that the water is flowing. We actually have a video showing this and talking about this a little bit more in depth, and I will link that in the description below if you are interested in watching that video. But you can see here, the flow rate is dramatically increased with the PVC because it is a smooth interior pipe opposed to a corrugated pipe. All right, so we went ahead and we put sediment in the PVC pipe here at the bottom. That way we can go ahead and kind of see what results we get when we start to turn the water on. Now we are going to start this with a low flow application. We're going to barely turn the spigot on because, as you can see, the cut when I cut this pipe wasn't 100% even. So the side walls are not very high on this compared to the corrugated pipe, but running it low flow, I'm pretty sure will suffice. So you can see the water has already found its way around that sediment clog right there, and it is beginning to carry the sediment and dirt with the water out to the discharge end. So we are going to slowly increase the hose as we go with this test. We wanted to see, just with a low flow application starting off, how well it did, and you can see it is moving that sediment through there pretty well. And as the water builds up in the back, it also begins to push more of it forward. Now we are going to turn that hose up a little bit more as this test continues here, but just to run it all the way down, you can see there actually too where the bell end is, how that sediment is dropping off of the bell. So that's why you want the bell ends facing the correct way. That way the sediment wouldn't be hitting that seam and that spigot end inside the pipe where it connects to the bell end. But the sediment is traveling through here virtually unstopped, and we actually had to go ahead and we had to put a shirt down here just to kind of filter the sediment, just because I didn't want that getting all down in the catch basin, because then I would have had to clean it out of there. So that's why you see a shirt at the end of the discharge, is to catch the sediment. But now we have the hose on full blast, and it is pretty much just pushing that sediment right through with no resistance. So this is why I say that a smooth interior pipe is always going to be superior to a corrugated pipe. The math doesn't lie, it's just the way it is, and that sediment is pretty much all cleared through the pipe. So I still will always stick to what I say, and that is that application determines the pipe type. The final thing that we're going to show you in this video here is we're going to dump a bunch more sediment into the corrugated pipe, and instead of starting with a low flow on the garden hose, we're going to go ahead and crank it up all the way, and we're going to see what exactly happens with this big sediment bulge that's happening in the pipe. So I have a feeling that it's going to go a lot quicker this time around compared to the last time, because we have a lot more head pressure that's going to build up in the beginning of the pipe while it's being backed up from this sediment clog. And you can see there that it found its way around the sediment clog, and it is now moving that sediment through the pipe. So this video is not to bash corrugated pipe in any way. That is not what this video is about. That is not the purpose of this video. The purpose of this video is to show the truth on what the math shows and what the math says. And it is so that you can choose the right pipe for the application that you are doing. Because at the end of the day, application determines the pipe. If you do not have a huge budget, corrugated pipe is more affordable, it's easier to install, and if you have the slope to work with, then there's nothing wrong with using corrugated pipe. If you have a higher budget and you don't mind the extra labor, because PVC is a lot more labor intensive to install, and it takes more skill, I would say, too, to install PVC. It's going to be a lot more cuts. You have to dig a lot straighter trenches. I mean, the trenches have to be perfectly straight with PVC because you don't have any bend with PVC. You have to be able to roll fittings with PVC compared to corrugated pipe. You don't need to roll fittings because you only have Ys and sometimes 90-degree elbows, and that's pretty much it. Other than that, you can bend the pipe in any direction you need to pretty much bend it. So it all just depends. There's a lot of variables and there's a lot of factors that go into it. Both piping systems are valuable. Both piping systems have their place, and both piping systems need to be installed correctly. You could have somebody install a PVC system and they may not install it properly, and it could fail within a matter of years. And the same is true with a corrugated system. So it all just depends. If you guys enjoyed this video, give us a thumbs up. It really supports us. It supports the channel. It helps out what we do. If you have any questions, leave them in the comment section below. If you live in the Tampa Bay area and you need French drains, channel drains, downspout drains installed, give Stormwater Drainage Solutions a call at 813-614-3456. We install corrugated systems, PVC systems, dual wall, triple wall. If it's drainage pipe, we got you covered. Give us a call.